Happy Sunday, everyone. Today's lecture or lesson is about, again, it's about differentiation or finding derivatives, but this time we're going to add some trigonometry into this. Some people hate trigonometry, some people have a hard time understanding it, so I guess just like the chain rule, we'll go very slowly, but I think you guys can get the hang of it. There's a couple things that you need to memorize that you just, there's no other way, there's no shortcut to it, there's no, cheating to it, you just have to memorize it. So here's 6. If you look at your screen, there are 6 different derivatives up there. 2 of them you already know. 1, you should know the derivative of sine. Oops. You should know the derivative of sine is cosine. So this we already know. And you should already know the derivative of cosine is negative sine. That one you should already know. But the bottom 4 are ones that you don't know yet. I'm about to teach you. The derivative of tangent is secant squared. The derivative of cotangent, that's what COT means, is negative cosecant squared. The derivative of secant is secant tangent. And the derivative of cosecant is negative cosecant cotangent. You should see a little bit of a pattern here. Tangent is secant squared. Cotangent is secant squared. Cotangent is negative cosecant squared. So it's almost the exact same thing. Like if it's tangent, it's secant. If it's cotangent, it's cosecant. And then I make it negative. If it's secant, it's secant tangent. If it's cosecant, it's cosecant cotangent. So there's a little bit of pattern here. And then again, there's also a negative. In addition to these, there are some formulas that you need to review that you should have learned in your previous classes, should have learned last year. One of them is called the Trig Identity. It's a formula. It's called the Trig Identity. But the formula is if you have sine squared of anything plus cosine squared of anything, that equals 1. And then if you forgot the definition of secant, cosecant, and cotangent, I'll write them out for you. Secant, the definition of secant is 1 over cosine. Okay, so far? And the derivative of cosecant is 1 over sine. So again, you get this little pattern here in case you are unsure where we got this. There's a pattern here. And then, let me just zoom in because I'm running out of space here. Cotangent. Actually, before I do cotangent, some of you may have forgotten the definition of tangent. The definition of tangent is sine over cosine. Since you know that, the derivative of cotangent, since they're inverses, all these are like inverses, cotangent is, and I'm running out of space, so I'll put it below, cosine over sine, or the inverse of tangent. Or another way to think about it is cotangent is the same thing as 1 over tangent. So if I zoom out a little bit here, if you could review, we got sine squared. We've got sine squared plus cosine squared equals 1. Secant is 1 over cosine, and cosecant is 1 over sine. They're inverses of the trig functions you should already know. Tangent, which you may have forgotten, is the same thing as sine over cosine, which means cotangent is cosine over sine. And sometimes maybe you can also think of it as cotangent as just 1 over tangent, which is how we got cosine over sine. So now that you know all of these trig stuff, now we should, basically, we're going to apply the chain rule, the product rule, the quotient rule, all the rules we learned, but now let's add trig to it. Okay, so let me just move over here. And let's do our first example. This one just says prove the following using sine, cosine, and quotient rule. It's actually a very common AP question to do is can you solve or can you prove a certain formula? And they give you some sort of hint. So this one, the hint says you have to use sine, cosine, and quotient rule. So what I'm going to do, it says take the derivative of tangent and you should get secant squared. And any proof, I'm basically going to focus on one side and try to make it look like the other side. In this case, I don't know what secant squared is or how to do secant. So I'm going to use tangent. If I want the derivative of tangent, okay, that means the exact same thing, and the instructions tell us a hint. This means the same thing as sine x over cosine x. Okay, so far? Now, I have sine and cosine, and then it says to use the quotient rule. So I'm going to apply the quotient rule onto this. Okay, so I'm going to take the derivative of the first one. Oops. I'm going to take the derivative of the first one, which is cosine, and leave the second one alone, which is also cosine, minus, because this is quotient rule, Leave the first one alone. Times the derivative of the second one, and this one is cosine, and derivative of cosine is negative sine. And that's all over the denominator squared. So remember, if I want to square a trig function, that 2, or this exponent, goes in the middle. So now apply the quotient rule. Okay. Now I'm going to simplify this. Cosine times cosine is cosine squared. And then I have minus sine x times a negative sine x. So what I'm going to do is I'm going to minus times a minus, or negative times a minus, negative times a negative is plus, and then sine times sine is sine squared. Now I'm going to use one of the trig identities that I learned earlier. Remember, we said that cosine squared plus sine squared, that's the definition of the trig identity. That's equivalent to 1. And now I'm going to use another identity that I'd used earlier. Remember I told you 1 over cosine is the same thing as secant. And since this is 1 over cosine squared, this is the same thing as secant squared. And in our proof, this is the exact same thing as what we're trying to prove. So, in proofs, you're not going to do very many in this class, but you might get an AP exam. Follow the instructions. So in the instructions, it said to use sine, cosine, and quotient rule. I converted tangent into sine and cosine. I did the quotient rule. I found out that this is the exact same as the trig identity, so this became 1. And 1 over cosine squared is the same thing as secant squared. Okay. Now, if we move on down, interesting question here. Remember, we're applying trig. It says here, find the derivative of each expression. This one I have x to the third tangent 4x. Now, which rule do you think is the first rule we're going to use? I see a power rule here. I see a product rule here. I see a chain rule here. I see trigonometry here. So there's a lot of stuff going on here. But which operation do you think is, the first one that you would have to do if you're doing order of operations? Or what's operation is going on here? Yeah, this is product rule. Okay, so I'm going to take the derivative of the first one. Oops. I'm going to take the derivative of the first one and leave the second one alone. Okay, so far? Plus, because this is product rule, I'll leave the first one alone, and then I'm going to take the derivative of the second one. And this is where it gets a little bit tricky. What is the derivative of tangent 4x? Well, you may notice that this is a chain rule. I have 4x inside of tangent. Or if you guys can't see that, if I could zoom in, this means the exact same thing as this, tangent of 4x, not tangent times 4x. So I'll take a derivative, this is chain rule, I'll take the derivative of the outside. So do you guys remember the derivative? Or if you don't remember, you can look at the top of the page. The derivative of tangent is secant squared. And I'll leave the inside function alone. Then I'll multiply by the derivative of the inside. Since the inside function is 4x, I'll multiply by 4. So simplifying this whole thing, what I'm going to do is I'm going to combine or make this right side a little bit more nicer or cleaner. Left side's already simplified. 3x squared tangent 4x plus, I have a 4 out here, I have an x to the third, so I'll just combine those, 4x to the third, secant squared 4x. And that is the answer or derivative of that function. Okay. If you have any questions, you're going to write this down in your homework, or if there's something you don't understand. Okay. Moving on to the next page. If you want to turn to the next page, I'm going to do 3 more problems for this lecture. A little bit more difficult here. I got 2 cosine 5 to the 3x. You may remember in one of my lectures, if you have multiplying by a coefficient, I could just move that to the side, or I'm just going to move it and then apply it later. So this 2, it's a coefficient. I'm going to leave that alone, and I'm just going to, I'm going to take this 2 and just move it to the side for a second. So really what I'm going to focus on is cosecant to the 5th power 3x. Somebody's saying, how do I find the derivative of cosine or cosecant to 3x to the 5th power? Well, let me rewrite it in a way that maybe we would understand. Can I rewrite this as cosecant of 3x to the 5th power? Okay, it means the exact same thing. And the 2, remember, I just moved to the side. This is one of those double, triple chain rules things. My outside function is to the 5th power. My inside function is then cosecant. And then my inside function is 3x. So I'm just going to apply the chain rule a couple of times. If I do the chain rule to the outside function first, I get 5 cosecant 3x to the 4th power. So all I did was apply the power rule to the outside function and left the inside alone. Multiply by the derivative of the inside function. The next inside function is cosecant. If you look at your table up, or if you remember, the derivative of cosecant is negative cosecant cotangent. And you may notice in the table it says the derivative of cosecant x is cosecant cotangent x. So in this case, since I'm trying to find the derivative of cosecant 3x, I'm going to leave the inside function alone. So it's negative cosecant 3x and cotangent 3x. After that, I'm going to multiply that by the derivative of that inside function. And you remember the inside function was 3x. Remember in the original problem, I had a 3x. So I'm going to multiply by the derivative of this one. That is 3. So now, I have everything sort of finished, so I'm going to combine everything. You may notice that I have a negative, and I have a 3, and I have a 5. All the coefficients, I have like a 5. I've got a negative 1. I've got a 3. So I'll multiply all those out. It becomes negative 15 cosecant to the 4th power of 3x cosecant 3x cotangent 3x. You may notice now that I have a cosecant 3x to the 4th power, and I have another cosecant 3x here that I'm multiplying by, so I can combine those also. Negative 15 cosecant of 3x to the 5th power times cotangent 3x. Now, you may be confused a little bit here, or you might think that you're finished, but you remember at the very, very beginning of the problem, remember I moved this 2 to the side. It was this coefficient. So now I could bring that back. I can multiply the whole thing by 2. And the real answer, or not the real answer, but the final answer is negative 30 multiplying by 2 cosecant of 3x to the 5th power cotangent 3x. Okay. Now, going to the next problem. Looks very, very, very tricky. But I got a plus and a minus in between here. So you see I have a plus here and I have a minus here. I'm basically looking at this as 3 separate problems. Okay, I'm just looking at 3 separate problems, and I'm going to combine all the answers together. Okay, so let me erase my previous work real quick. And let me work on this one right here. All right. The first one, I have negative 5t secant 2t. Which rule do you think is or which operation do you think is being done first? Yeah, it's product rule. So let's apply the product rule for this one. I'll take the derivative of the first one. Leave the second one alone. Plus, since this is product rule, I'll leave the first one alone. Times the derivative of the second one. The second one, you may notice, it says secant 2t. I got a trig function, and it's also a chain rule. I have a 2t inside of secant. So now I'm going to have to apply the chain rule. The derivative of the outside function, the derivative of secant, if you look at your table, or if you remember, is secant tangent. So this is secant 2t tangent 2t. Multiplied by the derivative of the inside, which is, the inside function is 2t, multiplied by 2. Okay. Now, how about this? I'll label this number 1. That's the derivative of the first piece. Actually, let's make it even easier. This third piece right here, this third piece is minus 3. What's the derivative of 3, or what's the derivative of minus 3? Yeah, it's 0. So we actually don't even care about that part. That part's going to disappear. Now, the second part is 2 tangent to the third, or 2 tangent of t to the 3rd power. I have a coefficient of 2 here, so you may notice I have this 2 here. I'm going to move that away, or move that to the side for a second, and I'll multiply that back when I'm done. So let's take the derivative of tangent t to the 3rd power. Somebody say, how do I find the derivative of tangent t to the 3rd power? Well, let's rewrite it in a way that maybe you know how to do it. Doesn't that mean the exact same thing as this? Yeah? So this up here, tangent to the t to the 3rd, means the exact same thing as this. So all I'm going to do now is apply the chain rule. What I'll do is I'll put the 3 out in front, leave the inside alone, and subtract 1 from the exponent. That's the power rule. Then I'll multiply by the derivative of the inside. I have tangent. If you remember, the derivative of tangent is secant squared t, because there's a t in this problem. And maybe some of you might think I need to do chain rule again. The inside function is t or 1t. The derivative of t is just 1, so if I multiply by 1, I still get the exact same thing. Looks like I'm done, but remember, I had that 2. I had this 2 that I put away for a while. I'll multiply this 2 back into the problem. The derivative of the second piece of this derivative is 6 tangent squared t secant squared t. So that's the derivative of the second piece. And remember I told you that third piece is just 0. So now I'm just going to combine these together. The first one, I've got this big mess here, so I'm just going to simplify it. Negative 5 secant 2t. I got this minus 5t, and I got this times 2, so that's negative 10t, minus 10t, and then secant 2t, tangent 2t. That's just the first piece, and then I'm going to combine that with the second piece. This is the derivative of the second piece, so I'll add that in, plus 6 tangent squared t secant squared t. So in case you forgot where I got this, here's the number 1 piece, and here's where the number 2 piece went. So that's how you find the derivative of that problem. Some of you may say, man, that was really long, or that was complicated. You guys, if you follow the examples, I think you guys will get it. We're running pretty long, so I'm not going to get to that last example. So this is the video lecture for Sunday. Hopefully you guys can finish this by midnight tonight. If not, at least send me a message or an email or something, and we'll finish this when I see you guys in class. So take care, have a good rest of the weekend, and goodbye.